about codecs, coder decoders, or vocoders, voice coder, same thing, or transcoding from one standard to another. And we like to use dedicated purpose chips to do this because then they can do it fast. They don't have all of the operating system overhead and things like that. So what we might see is that the media conversion is done by one box with dedicated purpose chips in it, and then signaling conversion is done by a separate box because that's all done in software with general purpose computers. The last H.323 entity is an MCU, a multi-point control unit. We used to call these things conference bridges. Now, it doesn't specify where the multi-point control unit actually is located. It could be inside a telephone, it could be inside a server, it could be part of the same box that the gatekeeper is on. In every case, there are two functions that have to be performed: the multi-point controller function and the multi-point processor function. The multi-point processor is a thing that takes the media streams and puts them together somehow and then broadcasts them back out to all of the participants. The multi-point controller is a device that sets up the conference call, and not just doing the H.225 and Q.931 call setup signaling, it also has to do the capability negotiation, the H.245. Since there are two functions to be performed, they don't necessarily have to be in the same box. There are two different choices. One is that you do have both functions, the processor and the controller, in the same box. So in theory that could be in a telephone, for example. Or you could have the control functions in one box and the processing functions in another. If you think back into our discussion of doing things into hardware versus software, probably we want to do the multi-point processor function in hardware. In other words, have a dedicated processor doing this. And believe it or not, video is easier to do than audio. One example of how we could do a video conference, let's say we had 5 participants. Well, you only really need to see the other 4. So we would have 5 different media streams coming into the processor. It would have to synchronize the scans and shrink down the image down to a quarter of a screen. And then it would put 4 people's pictures together to make a little montage and send that out to a particular terminal. But each terminal is going to get a different set of 4 pictures because you want to look at the other 4 people, not yourself. Audio is pretty hard to do because of all of problems related to echoes, and we have to adjust the levels on an audio conference. If one person is shouting a lot more loudly than all the others, then we have problems of deciding if somebody's talking quietly. How do we decide to actually add that into the overall sound that's generated and sent back to everybody? And you can imagine all the fun you can have designing switching algorithms or deciding whether we should normalize everybody before adding them together. And it's not trivial how to do an audio bridge. But we know how to do it because we've been in that business for quite a while. We would have a function doing that usually inside a telephone or possibly a standalone device, much like these Polycom conference phones that we have today. Just a bit of jargon and buzzwords here. The difference between a call manager and a gatekeeper. Well, a gatekeeper is an H.323 entity, so it's defined in that standard. Now, that may or may not have anything to do with the products that you're looking at purchasing from a vendor. And the marketing department of that vendor is going to come up with bundles, and they say, well, on our call management server, we do the gatekeeper functions, plus we've got integrated messaging, plus all of these fancy call control functions, and that is our call manager product. Another company might say, well, our Gatekeeper product does the H.323 Gatekeeper functions, plus it does integrated messaging, plus it does all of these fancy call management features. So it's really a question of bundling of products and then what the marketing department decides to call their product. Just keep in mind that a gatekeeper is a set of core functions for managing terminals, registration, admission, status, and call setup signaling. And then we've got just an endless list of other things that we could do, like voicemail, email, integrated voicemail and email, interactive voice response, ACDs. We could have interfaces to billing systems. We could have a billing system on the call manager platform. Let's try to keep functions and product packages separate. Now that we've looked at the H.323 entities, let's talk a little bit about protocols. Protocol is a term used to mean a plan or a method of actually doing something. We're always interested in standard protocols, and a standard is when everybody agrees, yes, this is the plan, no, not that is the plan, because there are lots of plans out there. And when we start talking about voice over IP, there are quite a number of standard protocols that we end up having to know about. One of them is LANs, because as we saw, by definition, an IP terminal plugs onto a LAN. So we have to know about how LANs transmit information around. And I can't emphasize enough how you should be watching the core training videos before this one. When we're teaching this class live, our course number 301, we have chapters on the fundamentals of telephony and fundamentals of datacom and networking that precede these discussions, so that when I say LAN frame, everybody knows what I'm talking about. If you're not familiar with the difference between a packet and a frame, then Understanding Datacom 1 is the course for you. You should go watch that one and then come back and watch this one. In any case, LANs transmit frames, and the way it works is that if you want to transmit information to another computer on a LAN, you make up a frame and you put the LAN card address, also called the MAC address, of the desired computer on the front of the frame, and then send it off onto the LAN, to the switch. And of course, since we're talking about voice over IP, what we end up doing is taking whatever we want to send from one computer to another and putting it in IP packets. And what we do is we put the IP address of the desired final destination on the front of the packet, and then that goes in a LAN frame and we send it to our LAN switch. So the IP packet has the IP address, and that identifies the far end. On a LAN frame, usually the way it works is that the address on the LAN frame identifies the next box it goes to in a whole chain of boxes. Now that's the short version. If you're not familiar with this, you really should do the long version. Everybody's heard of TCP/IP. Now the idea here is that IP networks allow us to move an IP packet from one computer to another particular computer, but it doesn't provide any guarantees that that's going to actually happen. It doesn't do any retransmission of bad data as a network service. We have to do it ourselves. And the way that that's commonly done is using a protocol called TCP, the Transmission Control Protocol. And this is implemented in software on the end computers. And when we want to send something, we actually give it to the TCP software that puts a sequence number and error check on our information. We stick that in an IP packet. It travels across the IP network, and when it gets to the far end, we pull the data out of the IP packet and give it to the TCP software, and this software checks the sequence number and error check. And if it fails the error check or it doesn't get there, there's a mechanism for retransmitting the data that's missing. This is for file transfers. This is when you absolutely, definitely want your stuff to get there, and if a piece of it doesn't get there, we retransmit the data. When we're discussing live streaming applications, there's no time to retransmit data that went bad. I mean, what are we going to do? Put the listener's brain on hold while we wait to retransmit that